It's Friday of the fourth week, and we have completed all of the initial look at the course content. So today was to finish up any content which we sort of finished, but we'll have time to ask any questions over maybe homework questions or such. But what I'm going to do is give a sort of a framework for the exam. I did receive a copy of the exam last night. I woke up at 2 a.m. and checked my email. I don't know. How many of you wake up like 2 or 3 and I'll check my email. I do that almost all the time. I said, oh, good. I got the email. So what we're going to take a look at is from the home page. So here's our learning activities for exam one. One of the things I'll let you know is as I'm going to show you the instructions. We'll go over the instructions for the exam, what's going to be on there and those kind of things. But in looking at the exam, one of the best preparations I think you can do is complete the homework. So the exam does follow along with the homework. The homework will probably over prepare you in some sense because but kind of be able to do everything. I've got you a list of sort of at the minimum be able to do this, but sometimes you're going to have to practice with the other ones. Train of thought. So maybe I should just jump into it. So anyway, yeah, do the homework. All of the homeworks, and what I'll do is over the weekend, I'll put a first update. I haven't put any grades or scores into Canvas yet. I will pull up the WebAssign gradebook. I will make the adjustments. Remember, if you have 80% or better, you'll have 100% on the homework. I'll put those scores in there. You may have some that you haven't started or that are low. That's fine. Just remember that will be an in progress. So sort of a first update. I will do it again after the exam, after the due date passes. Okay. The due date for all the exams, Friday night, next Friday night, after the exam. So the exam we're having in the morning, that's the best, it's not that you won't learn anything of doing it later, but it's better to do it before the exam so that you can do well on the exam because that is the largest part of the grade. I don't know, homework is what, like 10%, 20% maybe total. I don't remember. But I do know in the department, the exams have to be usually 70% or more. There's a few classes that's like 60 or 65%, but we're told exams are like 70% of the grade. So you've got to do well on them. So the homework's a good preparation, first of all. Secondly, we'll go to the exam resources specifically. So first of all, I went and I updated the department exam review. Not really much, but so it's got a couple of highlighted questions. So what I did is I said, compared it to the exam, what would be sort of like a minimum number of questions that you could go through so that you do at least these. And I think I came up with 7 of them. But you have to do them completely because it's not that there's just one question like this. There might be 2 or 3 questions that kind of, because they break it down into parts. We'll show you. There's some multiple choice ones. The multiple choice, you can only ask one part of a question, right? Because you got to choose that. So some of these will cover multiple questions. There's 13 questions total. I'm kind of doing things backwards, but what I wanted to highlight is I've highlighted questions that sort of do these at a minimum. Maybe start with those. It's not that the others won't be helpful. They will, and a lot of them are just similar to this. I just said, like for this one, I could have chose 3 or 4. They're both good linear programming ones, but I just said, do at least 3. 4 would be helpful because it's very similar in solidifying it. But what I wanted to, I wanted to go through and say, do at least these. So there's 3, 8, 9, 10. They don't, and we've talked about these 3-dimensional ones are kind of hard to do, so they didn't put any of those on there, so that's kind of good. There's just the analytical side, and I knew that some of the questions are going to be more simplified than what we were doing in class or in the homework. But be able to do one like 12, be able to do one with the Lagrange multipliers, that's on there, not a surprise, and be able to do one with the extreme value theorem. And just, it's really set up much like this. They want all those parts, okay? So be able to do those. So those, I think, are 7 problems. Those, make sure you focus on them, try them. If you have no clue on them, I'm going to do some videos on those. So that's where I'm going to start with my videos. I'll do those 7 as videos. And I will post them as individual videos so that you could jump to one or the other, and I'll label them with those question numbers. And then I'll come back and fill in with some of the others, because again, there is, if you can work this whole thing, you'll be just fine. Okay. The questions on the test, some of them, again, might focus on just a part of it. And I'll just tell you, there is one where you have to identify the graphs. There's a multiple choice one where you have to pick out the right region. Okay. So, which isn't on, they didn't have one like that in here, but it just, they have them in the homework. And then this one, there's the answers below, but again, I will be doing solution videos that kind of walk you how you would do each one of these, so that you can also do it for the essay type questions. They also want to see all your steps and all your work and that kind of stuff. So I'll make sure that's all there. But there's answers here, so you can kind of check. So there's that. Again, kind of updated, just giving you a little bit more focus. Just do those 7 at a minimum. And then, okay, if you got those down, you're going to do okay on the exam. Do some more practice. One of the things, let's see, where should we go for exam instructions? Let's talk. So this is the actual first page of the exam that they gave me. There's a little statement you sign saying that this is your work. You didn't get help. Of course, it doesn't say you can't pray to angels or something, but no human help. So there's 13 questions worth a total of 100 points. There's multiple choice short answer. Each of those are worth 6 points. There's 10 of those, so that's 60 points of the test are from either multiple choice or short answer. And when they say short answer, it's, find this point. So that you don't choose it, but you get the point and then you list it, something like that. And they say that, so you're just going to fill in those. And then there's 3 questions that are sort of like essay type questions, where they call them open response, free response, where it's more like a homework one, and you fill in some spots. And sometimes I'll show you the template. They'll want you to do all the parts, like on a Lagrange multiplier, you have to do all the partial derivatives and stuff. So it'll ask for it, sort of fill those in. That last one we were doing with the extreme value, we had to find all those points. They'll have a little table, fill in all the points that you need, the corner points, the region, and all that kind of stuff. So when I work through that, I'll work it in like I was doing the test. Okay, so you can kind of use that as a model, be able to do all those things, and you'll be just fine. What else is here? There's the last page is for scratch work. So you're welcome to bring your own scratch paper, but we don't include that in the test. So you can, that's just kind of your scratch. What you're going to have to do is organize it on the exam. So there is room within each question, some room. Again, you see me, I use more room than I need. So then they give us an extra page where you can put some additional stuff, and it's got front and back, but then it'll all be attached. You'll hold on to whatever scratch work you have. And I know it's a short time. We're told we've only got 50 minutes. And that's to make it consistent, because we only have 50 minutes assigned for this class. To those that meet twice a week, they actually have an hour and 15. They're told to shorten it. But again, if you practice, you should be able to get this well within the 50 minutes from this. So we'll start right at the time and keep going. Calculators, cell phones can't be used. Calculators you can use, but again, not the CAS, which will do algebra. I'm not so concerned with that, because I've tried to use them myself, and if you can learn how to use one of those calculators, you probably could do it by hand too. So it's probably easy. Anyway, and that's your cover page, and then it starts right into the exam. So I encourage you to kind of read over this so that when you get the exam, you're not, oh, I have to read this. No, you'll already know it. Okay, all you got to do is put your name on it and go from there. Okay, so that's the cover page of the exam. You'll be prepared on that, and it spells out what's on there. So 10 multiple choice open answer. I think there's, I don't remember, 6 or 7 are actually multiple choice, with the last 3 or 4 being just short answer, which means like find the point and put that there, or find this derivative. But they give you kind of like a little area where they want the answer. So they really are a short answer. And you don't have to show your work. In fact, any work you show is not considered. We only look at the answers. Okay, so it's right or wrong. Questions so far? Okay. The other thing I added is I looked over the test and thought it would be good to kind of give a content breakdown by words. So I kind of looked at each one, and if you can do all this, you're in good shape. Sounds like a lot. So linear programming, basically, if you're able to do that linear programming problem, you'll be able to do all 3 of these, right? Because it's all involved. Translate the objective function. So you're going to be given a word problem, and you're going to, from that, you're going to have to be able to pick out what is the objective function. You're going to have to be able to write that. So they won't tell you it's 3x plus 4y plus 6 equals the function, but they'll say the jujubes cost $3 and the Skittles cost $4, and from that you're going to have to come up with the equation. Okay, so just like in there, so you'll have to be able to do that. You'll also be expected from that word question to be able to write what the constraints are. And remember, the constraints could include x greater than 0, y greater than 0, but they don't oftentimes say that. So just the good news is they weren't too tricky on that. That's a multiple choice one. But just remember that and that will be kind of your reminder. You'll see one of those answers, but don't choose the one that doesn't have x greater than 0 if that's what really what a requirement is. You can't have a negative seen a lot of times. So, but be able to, from a word problem, set up the constraints. And again, there was a few in the homework. I've got one highlighted in the section, and then also be able to graph those inequalities with your graphing calculator. Do it in the version that the book did. Remember, the book shades the area we don't want, leaving the part we do want open and white, because that's what's going to help you the most. They follow that part in the test. So they're doing like the exam, or like the textbook has had us do, shade what we don't want, leave what we do want as a nice little open area, and you'll be just fine. But be able to do that. Okay, so, and again, you can go back. What you'll see is that's really from 6.1 and 6.2, what we started with. There is no direct questions from 4. 4 was really a review to get us ready for chapter 6, but it is not directly on the exam stuff from 4. We really just, the exam starts with 6.1 and 2. So that's that linear programming part. And then it jumps into chapter 15. So this is really all the things we did in chapter 15. And again, there's a few things we don't have to worry about. The 3-dimensional graphs and stuff, again, those are hard to reproduce, so they didn't put any of that on there. None of those circular graphs that some of us were having problems reading, those level graphs. There is one in the practice test, but there's not one on the test. It's just those are we're a little bit problematic. But what you do need to be able to do is, when we have a 3-dimensional function, f of x, y equals z, or more, we could, they had a couple that had a x, y, and z, which, remember, is really 4 variables, because it's the function equals x, y, z. So that's a 4-dimensional thing. We don't have to be able to visualize it, but we have to be able to evaluate the function at a given point. So you're given some x, y, and z's. plug them in, and come up with them. They may not all be numbers. Sometimes they may have plug in the numbers and figure it out. Remember, sometimes we were plugging in other letters and stuff. So just like in the homework. And again, so if you can go through the homework and be able to evaluate, you'll be good. Be able to determine the intercepts of a multi-dimensional graph, three-dimensional, full dimension. And how do we determine an intercept? If I want to get the z-intercept, for example, how do I get the z? What do I know about the z-axis? What do points look like on that z-axis? Let me think of the x and y. So let's go to 2 dimensions. And I am recording, but I can't. I left my pencil behind, so we'll do it this way. Let's go for a typical. What does, on a 2-dimensional graph, what do you know about the point of an x-intercept? Which is 0? Y is 0. Exactly. The opposite one is 0. X is some value. Y-intercept, y is a number, x is 0. And so if we want the z-intercept, what's going to be 0? X and y. So it's not so hard to find it. You just put in 0 for x and y. But you got to remember that. It says find the intercept. Oh, what does that mean? It means put in 0 for the other two. I want to get the y-intercept in a 3-dimensional space. I put in 0 for x and z. If I want to get the x-intercept, I put in 0 for y and z. Okay, so be able to find intercepts. And again, sometimes it's out there. It's not a hard thing to do if you know what to do, but it's also an easy thing to kind of forget about because we don't do it all that much. And you kind of think sometimes you think, oh, that's so easy, I will remember it. Those are the first things I sort of forget. Oh, what's your name? Oh, I didn't study that part. I forgot my name. So it happens. Okay, so definitely focus on that. Calculate the first partial derivatives as functions. So you'll be given a function, calculate f of x. And they use the type of notation that I've been using, that f little x. They don't use that funky letter, whatever it is, for the partials, that fractional type stuff that the book sometimes uses. So all of the notation will be, even the second derivative, it'll be f of xy or whatever they want. Okay, so they're using this kind of notation for first derivatives and second derivatives. So that's the notation they use. So go ahead and hopefully you're more comfortable with it. You got comfortable with the other kind, that's okay. Usually you can pull, but this is what they'll use for the derivatives. So be able to get the partial derivative, be able to get the second partial derivative. So once we have these, remember we get two second partial derivatives based on each of the first partials. Okay, so be able to do that. And then just remember that this f of xy is going to be the same as f of yx. So you kind of have a way to check if you did both of them. These guys always have to be the same. Then once you have these derivatives as functions, be able to evaluate them at a point. Again, nothing, not necessarily new because we were doing it with the original function, but be able to also say, differentiate, oh, they want that point. And again, our homework had us do this all the time. We found these derivatives, these partials, and then we're supposed to plug in, usually it was 1 and -1, a point x and y. We had to plug those in. So we've done that a lot. Just be able to do that. So evaluate at a point. Find critical points. Okay, so now that's, again, if you remember how to do that, it's not a big deal, but sometimes that's a block that comes, oh, what's a critical point? How do we do that? How do we find critical points? Given a function, so we're given a function, some f of x. How do we find a critical point? What's the first step? Set what equal to 0? So that's I would count that as a second point, second step. Set it equal to 0, but what do we set equal to 0? What's that? What was it? A partial? Partial? Yeah, you were right. Okay, so we first take the partial derivative, both of them, and we set them equal to 0. Okay, that's going to give us the critical point. Then we solve it with the, so in itself, and then whatever, these are something with x and y maybe, or maybe just x, or whatever they are, their functions, then solve for x and y. And then we get a critical point. Remember that critical point, it's a place that is a potential maximum or minimum. Because, and why we're setting it equal to 0 is because the tangent line at that point needs to be equal to 0. The tangent line comes from the derivative, basically, and so when the derivative is equal to 0, that's the slope of the tangent line. So all this stuff coming together. That's why we set it equal to 0. You don't have to explain that, but you have to know that's what we're doing. And then we solve for x and y. So it's a little bit of a process in itself, and it can get out there. And it's one of those things, again, that you can study and maybe forget. But if you consciously try to say, I'm going to remember what a critical point is, to get a critical point, I got to do pretty much 3 things. I've got to take the derivative, the partials, I've got to set the partials equal to 0, and then I've got to solve for the x and y. Okay, and that will give me my critical points. But again, that's something we've done a number of times, but just make sure. But it's also a lot of these things, as we went through that was one step. And then what did we do? We had maybe a second derivative test to figure out whether they're a max or a min. And so there's all these things doing. Some of these questions, you'll just be asked for the part. Get the critical points, boom, that's done. They won't have you do the whole problem, and sometimes it's in the middle, right? And remember, sometimes they may ask you for the second derivative. They didn't ask you for the first derivative, but to get the second derivative, what do you have to get? You have to get that first derivative. And it's like, well, they didn't ask for it, so I got to do all this work for nothing? No, to get the second, you got to take the first. So, okay, so there's some things like that. Find critical points, and then be able to classify those critical points as max or mins, relative or absolute. Again, we know you don't have a 3-dimensional graphing tool, so we're not, but we're going to rely on that second derivative test. And I put that here, critical points, classify critical points using the second derivative test. Know what that is. I cannot, coordinators decide, you do not get a sheet of notes. They do not provide any formulas, so that you're going to have to remember that Hessian formula, which is not too bad. Remember, it's about the second derivative test, so you can kind of remember that. It's xx times, so it's the 2 derivatives that are sort of the second derivative that comes from the same one, so xx and yy, and then you're going to subtract xy or yx squared, because remember, these are both the same. So I kind of remembered it this way. So you take all, you're going to have 4 second derivatives, partial derivatives. Take the first 2 that have the same letters, multiply them. Take the 2 that have opposite letters, multiply them, and then subtract that, and that gives you the Hessian, or the H, right? Which is just some number. This is the harder part, is remembering what the Hessian means. And be honest, don't test me on that. I would fail right now. But I know we were doing it the other day. If it's negative, if the Hessian is negative, we got a saddle point, right? If the Hessian, so that's the easy one. So just kind of remember, if it's negative, I better be sure. Is anyone, okay, good. Yeah, we were working on that. So if it's negative, it's a saddle point. If it's 0, it's inconclusive. We don't know anything. And then if it's positive, so just kind of like if H is positive, H is negative, we've got a saddle point. If H equals 0, who knows what's going on? We don't. And if H is positive, then there was two possibilities, and it was all tied off of the derivative of xx. So now it depends on whether this derivative is positive or negative. And this one, you want to think of a quadratic equation. The leading coefficient. So if this is negative, what does that mean? Oh, the other way I remember, negative things make you sort of frown, right? So you're going to get something like this. So it's going to be a max. So the negative leads to a maximum. If it's positive, that makes you smile. That's going to lead to a minimum. Okay, so just think of it as a parabola, the leading coefficient. But that's something that's you're going to have to work through a bit. Again, maybe have a note card where you sort of codify it in your own, and something that makes sense to you. Don't just copy what's in the book, because it's too wordy for me. It doesn't really make sense. I would go with something more like this. And again, you could do this just as xy squared, because these are going to be the same, so that's the same thing. But this is how I really remember it is, okay, it's all four partial derivatives. The ones that are alike, multiply them. The ones that are different, multiply them. They're going to be the same, so square them and then subtract them. But write it down in the way that you do, and then so as you work through problems, look at it and make sure it makes sense to you. Okay? Okay with that? Second derivative test. Be able to determine marginal cost, revenue, profit. And what is the marginal? How do we get the marginal? By the derivative. So it's really, we're already having you do that somewhere else. You just have to remember marginal is a code word for get the first derivative. So yeah, that's what that, so it's kind of a meaning. And again, this all goes back to 210. Whenever you took 210, a lot, we were doing this, but again, now we're in 3 dimensions instead of just 2. Okay, and that's a key part. And then be able to solve an optimization problem using the Lagrange multiplier method. And again, again, don't test me on this yet, but the Lagrange multipliers, we had a formula, right? I'm not even sure I remember what it was, but so Lagrange multipliers, we had a function, we had a constraint function, we had to make sure it was equal to 0, and sometimes it wasn't. It was like 2x plus 3y equals 4, so we had to get it equal to 0. But this is a constraint. And this was the objective function we want to maximize, right? And if I remember, and maybe someone could look at their notes to make sure I get this right, because again, I think it was just the function itself minus some number, that's the lambda, that's the Lagrange multiplier, times this g of x. Did I get that right? Okay, thank you. Thanks for checking. Okay, but the Lagrange multiplier method is just, okay, that gives us a new function, this Lagrange multiplier function. But to find the maximum or minimum, then we're using this, we're taking the partials of this function. Oops, not f, that's why. And I'm going to go through and work a video of them, and when I do those, I will work them very carefully. When I come to class, I look over the problems, I'll even look over the solutions, but then I try to kind of forget them, because what I want you to learn in class is how I think through problems, hopefully teaching you how to think through a problem. When I do the solution videos, I want to give you something that's smooth and correct the first time. I don't want to make a mistake and then have to, so I sit down and I do them first, and then from my notes, I will make it nice and smooth for the solution problems. So I will do some of these, because again, remember that my big problem is once you get these, what the thing you want to solve for, you want to solve for lambda, plug in that, so then you need that. That's where I was having some problems. We don't solve for x and y like we do everywhere else. It's kind of not natural, but we're supposed to then solve one of them for lambda and then plug that in the other one, and then we can solve for just x and y, and we do all that kind of stuff. But again, I'll go through an example more smoothly than I did in class, and try to, and again, I do it in a way so that you can just kind of watch it. And I'll do multiple. I will eventually put solution videos for all of the review questions. It's always helpful if you can kind of try to work one on your own, but you might need to look at one first and then try one that another version. And again, you go back to the homework and stuff, try to do those. But it's kind of, I have a three time rule. So first time, a lot of times you need a lot of help getting through one. Second time, a little bit of help. And third time, if you can do it sort of completely on your own, that's good. And sometimes maybe a fourth or fifth time, but that third time might be multiple times, but that's kind of the learning. So Lagrange multipliers, and then we did what we just did on the finding an absolute max or min based on the extreme value theorem. And that's something that it was really nothing new. It just said that if it's bounded, if all these things happen, and there's this boundary, then there will be one. All the techniques to get that are what we've been doing here. So again, I will go through on the video one of those in sort of a smooth step-by-step, and I'll diagram out so that you can, okay, you do this, this, and this, and then you're all good. And again, I'll do it more smoothly than I did in class. In class, I'm trying to also model how you think through things the first time. And what do you do when you don't go the right way? Which I have a natural attempt to go the wrong way. I don't know if, like when I drive, especially like on a motorcycle, it's really important. You need to look where you want to go, not where you don't want to go. But I see a pothole, and what do? I look at it, and oftentimes I ride right over it, and I go, dang, I wanted to miss that. I forget I can't look at that pothole. I have to look where I want to go, especially on a motorcycle. Car, you just bang around, you're okay. Motorcycle, it's not too good to go through a pothole because you only got two wheels and balance can get off. But look where you want to go, not where you don't want to go. But it happens. Okay, so this is kind of a again, and we've done all of this stuff, but this is kind of there's a few questions from here. This is 6.1 and 6.2. Be able to do those. These are all this kind of brings all of chapter 15 together. And then we kind of 15.1 and 2 were kind of techniques that we ended up. It was really 15.3 where we started finding max and mins. And then we got some special techniques with the Lagrange multiplier still to find maximum minimums. And then the extreme value theorem, basically we went back and tied everything together, constraints. So 6.1 and 2 gave us this concept of constraints and sort of a feasible region, but it was in 2 dimensions. Then we kind of took those examples and went into 3 dimensions. And that's the stretch we're giving you, is, getting you to think with multiple variables that way. Okay. Questions? Does that feel like good enough information to get you prepared? So we've got a practice one, and I really like this one. In 2.10, I'll just be honest, is they oftentimes would take questions sort of from the homework, but they would twist them in a way that you had to do it slightly differently. And there was sort of a trick they were sort of made to be tricky. What I see here, it's all just like the homework. Okay, they did. I was almost going to skip 3 dimensions when they had the X, Y, and Z, but I thought, well, they got 1 or 2 questions in the practice, and it turns out on the exam they do. Those are not any. So you just want to be able to see those because it's not really any different than just X and Y, but yeah, there's a third variable, so we use the same process for getting the partials. But we're freezing 2 variables. If we want the partial of Z, we got to freeze X and Y. we want the partial of y, we've got to freeze z and x. So it's a, you know, again, if that was the first time you saw it, that's going to be a challenge. But that's why I highlighted some of the questions in the practice test that had those, and we'll do those. What's that? Well, you don't have to. You don't ever have to do anything that you don't want to do. However, if you do it, I am counting that as the quiz. So, but it's kind of an honesty thing. You're going to upload. So after the exam, you'll have, I'll make like I'll put an assignment in Canvas where you'll just sort of upload a screenshot or whatever you do for finishing up for working on that. You will upload something and that will give you the quiz points, which is 10%. I would suggest working at a minimum the ones that I've highlighted. But as many of the other ones would be good. But there's, again, you're just going to upload something. What I'm going to see in Canvas is that something was uploaded and I'm lazy, so I'm not going to view it because it's just your scratch work, right? You uploaded something, what that tells me is you did it. The thing is, if you did it, you'll do well on the test. If you didn't, you might not do so well on the test. Or maybe you'll do well on the test because you maybe just kind of already know this stuff, but that's usually not the case that happens. Usually what I find is if you do the review, you will do well on the test. Because remember, that review was put together by the course coordinators. Who wrote the exam? The course coordinators. There's two of them, and so they've been doing this for a while, and they're very close. Okay. The only other thing is there was a few in there, like in the multiple choice, that were a little bit more like the homework than what they had in here. They didn't have any one where you had to choose the right feasible region, but the homework did. So kind of be able to do that. So that one I highlighted for you. So the exam review will serve sort of two purposes. It will definitely get you well prepared for the test, but either if you write it out, you know, just take a shot of it, you can upload it, and it doesn't have to be a PDF, just any file. If you use a system and you're writing on the screen or something, whatever, take a screenshot, upload a file, and you'll get all the points for the quizzes. And again, that's going to be the best preparation. What I will do, so the goal is over the weekend to get at least those 7 videos produced, posted. Monday and we meet Monday and Wednesday. Monday and Wednesday we have as open review days, so that's when I'll start taking on. I guess my first thing to sort of focus on is maybe some of these the ones that I didn't take a video on, because if you had that, watch the video, or if the video didn't do it for you, I'd be happy to go through in class and maybe, because sometimes we need a little bit of back and forth. Why did I do something? Maybe I didn't explain it. Or some of the other review questions, you know, work at different examples. It'll also be a space where you can come and maybe we don't want to see maybe you just want to work some and be able to ask individual questions. So we'll leave those kind of open and fluid, but it'll be opportunities to get whatever you need. If you've got questions, come. And I'll bring my right tools. So at least whatever I do and we do in those classes, I will do through the screen so that that can be recorded. And if you're not in class, at least you can watch what happened and see what types of questions. But it's for me, it's more like there's no new instruction, but it's more about giving you the space to do the studying you need to do. And so if you're in a mindset that, hey, I think I've got all the instruction I need, I just need to buckle down and get some of this done, I need to work on some of the homework, whatever, that's fine. And again, if doing it someplace else other than the classroom, again, I want you to learn the stuff. I want you to do well on the test. And I want to be here for those who need that, but also give people the freedom who, hey, I know I learn better over here or whatever. I don't have to drive the 45 minutes in and 45 minutes back, and maybe I'll stay home and just buckle down and do these. Whatever is going to best prepare you for that exam. Awesome. And once you learn something, if one of the best ways of solidifying things is explaining it to somebody who doesn't quite understand, um, because then you're going to actually understand it better, and they will understand it hopefully better. And usually, sometimes it's better to learn from someone who just learned it, because I miss out on things. I forget to explain things where someone else will say, "Oh no, you got to do this." So someone who just learned it or is in the process of learning, when they explain it, oftentimes will be more helpful to those who are kind of struggling, and it will also help that person who's learning it to solidify it. So that's another thing is, we may have that time to talk with each other. Make a little mini study group but some of us, I don't know, I just want to study on my own. So, but sometimes, there's that helpfulness of it. But do what, part of what this learning math is to get you to learn how you learn, right? If you know how you learn best, then you're really powerful and going forward, because whatever job you get into, you'll apply maybe some of this, but maybe you don't even apply any of this. But I guess I liken it to like playing a sport. There's a lot of different sports, but how do most people, physical sports, what do? We go to the gym. You go to the gym, all the gyms are pretty much the same, right? They got the running machines to help you with the cardio. They have weight machines to help you with that's all they got. You go do that, that prepares you to play soccer, football, baseball, ping pong, whatever. All those sports need those kind of training. Math is here as a academic training to prepare you to know how you learn technical things. You go to the job, is you might say, hey, I never use calculus. Well, maybe not, but what you're using is what you learned about how you learn. And you've learned how to organize that thought. That's what math did to me. I became a math teacher, so I do use all the stuff I learned, but unless you become a math teacher, you probably won't use specifically these formulas and stuff. But what you're learning is you're building a way of thinking and problem solving that's going to help you in the future. Okay, I got nothing more. Any questions? We could start. Well, it's not that much early, but 5 minutes, 7 minutes. So we can start office hours early. I'll be here. I got another meeting I got to get to, so I got to go about 10 o'clock. Yeah, I got to leave here by about 10, which is a little early, but we got the rest, and you can stay here if you'd like. We have the room, officially we have the room here, so I'll be keeping office hours here right after class until about 10 or 10:15 most days. Today it'll only be till 10. Good one.